something, they can go back. All right, summation notation. So summation notation is it is also called sigma notation. Okay, it is also called sigma notation. Yeah, for some sigma notes. And it's a really, basically, stuff in math notations are kind of usually shortcuts. And so we don't have to write out a bunch of things. If I show something in summation notation, it's telling you what to do, okay? So summation notation looks like this. We're going to put a big sigma symbol. And then what happens right after the sigma symbol is you're going to get some kind of a formula. We'll call it A sub k. And we're just showing, just relax. This k, sometimes we've been seeing this as an n, right? Okay, so for some reason for summation notation, you usually see one of three letters. K, N, or I, and it's called the index, which is why they probably call it I, but K and N is probably what we're going to use the most, okay? So what is this? This is going to be an explicit formula. Just the A sub k part, okay? And if you're wondering what that looks like, look down at the bottom at examples 3 and 4. Do you see, like in 3, it's n squared plus 1, and then in 4, it's 3k minus 2. And what that formula tells you is how to find terms, okay? So you're going to, we've been doing this all along, guys. We've been finding terms, correct? But now we're going to add this symbol to the mix, which is the summation part. So when you see this symbol, it means add things up. So you're going to be adding up the terms of the sequence, okay? The problem with that is if I have to tell you which terms, because otherwise, if we could keep going forever, right? Could we just like keep finding more terms using that pattern? So then we have to say which terms do we want to add. This is called the index. So at the bottom of sigma, you see it tells you which terms. So typically we start at term 1. So A sub 1 would just mean term 1. And then there's going to be a stopping point. I'm going to put n there because it's going to change. So this is the starting term number. And this is the stopping term number. And those are all the little parts of summation notation. Okay. So today we're mostly going to practice just writing out the terms, and we're also going to practice writing the actual summation notation. But what if you saw this like next week when you see this and I'll say find the sum, what you're going to actually do, and we'll do it a little bit but just with our calculators today, is you're going to actually find these terms, and instead of just listing them, you're going to add them until you get to the last term, the stopping term number right there. Okay, so I should have left more space for this. This whole process is called a series. And so a series is just simply the sum of a sequence. And so when I start using that word series today, all I'm asking you is to add up the terms of a sequence. That's all that means. Okay. Nope. Whatever. Okay. Let's practice. So today I'm going to just practice writing this. Notice I said do not find the sum. Okay? All right, so let's put the little pieces together. So first of all, I put my summation notation symbol. I'm going to put it down here just in case I need some space for the work. And the next thing we're going to do is we're going to go right here and we need to find the explicit formula for the sequence I gave you. Okay, so we're going to look on our board up there. What kind of sequence is this added together? Is it arithmetic or geometric? Arithmetic. So we look at that top formula and we're going to write, we'll just use n's, okay? A sub n equals 3 plus, what's d? 2 times n minus 1. And just because I would like to have it simplified, let's distribute. Okay, so we got 2n minus 2 plus 3 would be plus 1. We're going to go ahead and put our explicit formula right here. And this is telling us, hey, this is how we're finding our terms. So we are starting this, we assumed that this was term 1, yes? So we are going to start this for term 1. However, we need to stop it at this term. So we don't put a 101 at the top. We need to know what term that is. Does anybody know how to find that? Can we just set this equal to 101 and find n? Absolutely. So we're going to set 101 equal to 2n plus 1. Would you solve for me, please? Okay. And then there we have it. We've represented that series using summation notation. Okay. Not too bad. On this one, do you remember how in our opener I said I was going to foreshadow what we were doing later on? Do you remember? So this one we're going to be able to figure out the last term because I wrote it like this, okay? All right, this one's actually a little bit easier because I think we can just go right to putting it in the middle. I don't think we need any workspace. What's the explicit formula for this? It's geometric. And I kind of gave you a little hint right there.
We should do that too.
Okay, I'll show you my tricks for that. It's kind of like if you think of, I don't even know. Hold on. Do you agree that that is the explicit formula for that sequence? And we are starting this at our first term. And I actually was nice to you and I gave it to you in unsimplified form. The last term is 40 times 1/2 to the 12th. What term is this? This is the 13th term because 12 is n minus 1. Now, technically, I kind of draw mine at an angle, but here, let's practice. This is the same. All right, so you start.
Wait, is that like, I think I've seen that before, like a
Probably.
Oh, because like fractions.
Yeah. You can do it like that if you want. Oh, here, I'll show you. So do like a little straight up and then go flat across and then do like in and back out and then flat across and then up. I just go fast, sorry. I just go.
Yeah, I like this one.
It's cute. Okay. All right, so then the last thing we're going to do is we're going to go the other direction. There's several ways we can write out terms. I don't care which one we do. Let's do question 3, okay? So when I give you the actual summation notation, then you are going to use this to write out the terms. And so you start down here, n is 1, and you put in 1. So what's 1 squared plus 1? 2. So the first term of this is 2, and then plus Now I'm going to find out the second term. So I started at 1. I'm going to keep plugging in numbers till I get to the number 5. So what's 2 squared plus 1? Okay. What's 3 squared plus 1? Can we do it in our head?
3 squared plus 1.
10. All right, let's keep going. What's 4 squared plus 1? And what's 5 squared plus 1? Okay. And then, so now I have, those are all, that's the whole thing expanded. And then the last thing I do is just, I'd add them up. Okay, so it's 2 plus 5 is 7, plus 10 is 17, 17 plus 17 is 34. What's 34 plus 26? 60. Okay. So do you feel like you want me to do 4, or do you understand the process? I'm giving some nods. Hold on.